Now let's solve this given differential equation using the separation of variables. So we would like to end up with an equation with y equal to something. But first, let's try to separate this differential equation by means of isolating one type of variable on one side of the equation. Let's use y for our left-hand side and x for our right-hand side. So we'll have, again, x, the first order derivative of y with respect to x is equal to 4y. So that we would like our y to be placed on the left-hand side, we can multiply both sides of the equation with a rational expression with denominator x. So that this would be cancelled, okay, later. At the same time, of course, do that on the other side as well. And then we are going to multiply d of x and our as our numerator, so this would be cancelled here, leaving only d of y on that side of the equation. Do the same thing on the other side. But of course, on our right hand side, we also have variable of y. Let's multiply this here with y, so that this would be cancelled, and that so that our y will only appear on the other side. Hence, let's do it like this. D of x is removed here, so you have d of y over y. On the other side, y is removed, so you will have 4 over x d of x. So we have now separated the variables. To continue with our task, because we would like to solve this equation, let's integrate both sides. So you'll have here the integral of dy over y is equal to the integral of 4 over x dx. We can rewrite it in this manner. The integral of 1 over y dy is equal to, moving out the constant, the integral of 1 over x dx. The integral of an expression where a numerator is 1 and then you have a variable on the denominator is just equal to the natural logarithm of the same variable, the absolute value of that. So that would mean on the other side, that's 4 times the natural logarithm of the absolute value of x. And this time, let's use here plus c. Of course, you could also have plus c on the other side here, but since we would like to solve this equation in terms of y, that will be moved on the other side as well and will be combined to another expression or constant c. So nevertheless, let's just have it like that. This could also be equivalent to without the absolute value notation. So you have the natural logarithm of x and then plus c here. To continue with this, because we would like to reach an equation y equal to something, let's remove the natural logarithm by using the exponentiation here. Natural logarithm of y. On the other side, you have e. All of this expression will become the exponent plus c. Take note, we have addition of exponents, so this could be written as, you have e to the power of 4 natural logarithm of x times e to the power of c, the reverse of the multiplication law of exponents, because when you multiply expressions with the same base, add the exponent. So from a sum of exponents, you can break it in this manner. We're doing that because we can simplify this form now, and before we do that, actually, let's also use a certain rule or law for our x here, because you can express x to the power of 4, making this an exponent of x there, times again e to the power of c. So we can simplify this, leaving y is equal to x to the power of 4 times e to the power of c. If we let e to the power of c as a certain capital letter c, then we can write now that our equation is y is equal to x to the power of 4 times your bigger c, or y is equal to c x to the power of 4. This is now the solution of the given equation. We did this, or we solved this, using the concept of separation of variables. But of course, if there are additional concerns, like we are trying to get a specific solution, given a situation where x is equal to something and y is equal to something, we can use that to get the value of c, and whatever would be that c, substitute here for us to have what do you call this one, an example solution of our given equation. But nevertheless, we did this by separation of variables. Thank you very much for watching.